Children, today we are going to discuss objective bits in 15th group elements. 15th group objective bits. So in objective bits I was sent already in assignment for soft copy. Now we are discuss about in class works one by one bits. You see the assignment bits, children. That is assignment 1. Assignment 1. Here the first question is given as phosphoproteins are present in. That is one of the occurrence of phosphorus. That is phosphoproteins are present in milk, eggs. Both are present in the phosphoproteins. So it is present in milk and eggs. That's why we choose the option, children. The first question is C. At the same question, slight mistake is that, children, phosphoproteins are not present in. Just to correct the question, phosphoproteins are not present in milk, eggs, both of A and B, ghee. Here is not present in ghee. So that is why here the second question is choose as answer B. Third one, correct order of melting points. Generally, down the group, melting and boiling points are increases due to increasing the atomic mass. Here, slightly they are varying atomic masses. That is about orders of nitrogen, phosphorus. Next is about bismuth, antimony, and arsenic. So this is the order of atomic order of melting points in 15th group element: nitrogen, phosphorus, bismuth, antimony, and arsenic. So that is why we choose the answer C. Next question, children. The element present in fluoropatite. It is also one of the mineral of phosphorus. So that's why here the formula representation is what is the formula? Fluoropatite. Here Ca3 PO4 taken twice, as well as fluoropatite means here CaF2 also. Here ratio is about 3:1 ratio. So 3:1 ratio of calcium phosphate and calcium chloride. Here given element present in fluoropatite. Calcium is present, phosphorus is present, fluorine is present, oxygen is present. That's why here choose the option calcium, phosphorus, fluorine and oxygen is present as which one here? Any nitrogen is present here? No. That's why option A is wrong. Option C also wrong. B option, calcium and phosphorus is only not correct. Here fluorine also present. That is why here choose the calcium, phosphorus, fluorine and oxygen, children. That is why your option B is correct, children. Fourth one is D correct. Next question number 5. The oxidation state is not exhibited by 15th group elements or 50th group elements. Every group of the elements exhibits maximum oxidation number equal to group number. So that's why a 50th group elements means maximum exhibits the oxidation number up to +5 only, children. But here given not exhibited by 50 group elements is 6 is given answer. That's why your option D is correct. Not exhibited by 50th group elements +6. Next, sixth one. The bond energy of nitrogen molecule in kilojoules. Nitrogen molecule exhibits the triple bond. It is very high bond energy. So now we are given values which is the highest bond energy. This is about nearly 941.4 kilojoules per mole. This is bond energy of nitrogen molecule. That is why at room temperature nitrogen molecule is inert nature due to high bond dissociation energy. Next, children. Oxidation state of plastic for phosphorus is found in Here given compounds, first compound can taken as H3PO3. Here oxygen state of phosphorus. Here 3 hydrogens can taken as plus 3. It is a X, so it becomes taken as minus 6 is equal to 0. X is equal to how much, children? Plus 3. So H3PO3, phosphorus oxygen state plus 3. So that's why your option choose as A option. Samantvani A. In case of H3PO2 is given. H3PO2. Here plus 3, here plus X, so minus 4 is equal to 0. Here X is equal to how much, children? Plus 1. H3PO2. So that is not correct. Next here, 7th one, A option only correct, children. Next, can choose 8th one. The stable oxidation state of bismuth. So here, this group of elements exhibits the oxidation states are plus 3 and plus 5. In downs the group, plus 3 stability increases, plus 5 stability decreases due to inner pair effect. So that is why in 15th group elements or 50th group elements, which is the last element, children, bismuth. Bismuth state is stable, plus 3 state compared to bismuth plus 5. That is why, children, any one of the bismuth compound can take BiCl3 and BiCl5. Which is the stable compound? BiCl3 is the stable compound. Because of your BiCl3, bismuth exhibits plus 3 state. That is why BiCl3 is a stable state. So now the oxidation state of bismuth is how much? Plus 3. Stable state. So then can taken as your option B is the correct option. 8th one. Next children. 9th one. Here given compounds HNO3, NH4NO3, N3H, H3PO3. Match the following here. Already know H3PO3 oxidation state of phosphorus is how much? Plus 3. Here see, D is given H3PO3. H3PO3 plus 3 oxidation state, here 4 is there. That is D is 4. Here D4, ABC options are there. That's why you can choose in ABC. Here, again, observe here, first compound is given HNO3, nitric acid. Here, oxidation state of nitrogen is how much? Here, plus 1, plus 6, minus 6 is equal to 0, X is equal to how much? Plus 5. So, nitrogen oxidation state is how much? Plus 5 only. So then, here A is can choose as 3, Roman number 3. Here, Roman number 3, only one option is there, children. That is why, which is option here? Option A is the correct answer. Question number 9, option 9 is the correct answer. Next, like that, here observe the remaining options also. One more is given NH4NO3. NH4NO3, here nitrogen atoms oxidation numbers find out, but here different positions are there. That is why it dissociated into NH4 plus NO3 minus. NH4 plus NO3 minus. Now you can find out separate oxidation numbers. This is X plus 4 is equal to plus 1. X is equal to minus 3. Again here NO3 minus is there. X minus 6 is equal to minus 1. X is equal to plus 1. Then what about oxidation numbers here? Minus 3, plus 5 oxidation states in NH4NO3. That's why B is Roman number 1. B is Roman number 1. Next here N3H. It is one of the hydride of nitrogen, hydrozoic acid. Here in hydrates of 15th group elements, this is only acidic nature, children. Remember, in hydrates of 15th group, which is acts as acidic nature, that is called N3H. It is also one of the framing the bit. This name is called hydrozoic acid. In this compound only, fractional oxidation state is possible for nitrogen. So which compound fractional oxidation state is exhibits in the nitrogen element? Hydrozoic acid. Formula N3H. Here observe here, 3 nitrogen atoms are there, then taken as 3x plus 1 is equal to 0, x is equal to minus 1 by 3 children. So therefore, your N3H oxidation state is minus 1 by 3. That is C is Roman number 2. So already know D is H3PO3, H3PO3 oxidation state plus 3. So that is why here all are match the correct one is option A is correct, children. That is why 9th question. Which is correct here? Option A is correct. Next children. After I go on, next question number 10. Nitrogen forms N2, but phosphorus forms P4. What is the reason? N2 means here nitrogen exists as triple bond. It is a diatomic. But phosphorus molecule exists as the tetraatomic molecule. Tetraatomic molecule. So what is the structure of P4 molecule? There 4 phosphorus atoms are occupies the tetrahedron corners children. This is structure of P4 molecule. So then, each phosphorus atom formed by how many bonds? 3 bonds. And also here the phosphorus atom contains 1 lone pair of electrons. So like that, every phosphorus atom is formed by 3 bonds along with 1 lone pair of electrons. Here 3 bonds means here, which bonds are formed here? Here P5 bonds are possible. Here P5 bonding is weak bond. So that is why here phosphorus is exhibits the here P4 molecule, but N2 is exhibits the diatomic molecule. So now here P5 bonding is weak. Next children, question number 11. Now 10th one is which is answer? Answer B is correct. 11.1. The trend in hydrates from bismuth to nitrogen. You are given trends of hydrates from bismuth to nitrogen. Bismuth to nitrogen. What happens here? Bond length. Bismuth to nitrogen means bismuth is here, bottom is there. Nitrogen is top of the position. So then arrange the elements like this: nitrogen, phosphorus, arsenic, antimony, this one. So what happened here? Bond length increases. So wrong. Your bond length what happened? You are asking bismuth to nitrogen. Nitrogen to bismuth, bond length increases. But bismuth to nitrogen, bond length decreases. Bond length. Bond length decreases. So now, which is correct answer? Bond length decreases. But acidic nature. So this first elements, bismuth is metal. Metal hydrates are here. Here what happened? Hydrates. Here bismuth hydrate is what happened? More acidic nature. Bismuth hydrate. Because of it is unstable, bismuth hydrate is readily producing of hydrogens. So, but you are given acidic nature increases, but not increases bismuth to nitrogen. Acidic nature decreases. Ammonia is a strong base. That's why weak acid. But you are given more wrong. Bond energy. For what happened here? Ammonia is stronger, but bismuth to here bond energy increases. Bismuth to nitrogen. But here given decrease wrong. So now only bismuth to nitrogen what happened? Bond length decreases. That is why the 11th question is used as here B option children. Next children, the element which forms acidic hydride already discussed here. In formation of hydrates in the 15th group element, only nitrogen forms acidic hydride. The formula of the acidic hydride is N3H. This is which element is formed? Only nitrogen element is formed children. That is why the question number 12, which is used answer A. The hydride name is hydrozoic acid. Formula is N3H. So that is the one. Next, 13. Which of the following is both neutral and paramagnetic? So neutral and paramagnetic nature. Here observed here N2O is neutral only. NO also neutral only. NO2 is of acidic nature. N2O4 is also acidic nature. Next, magnetic behavior. N2O to absorb here, how many total number of electrons? Nitrogen is atomic number 7. That means 7 electrons. 2 nitrogen means 7 plus 7, 14. Oxygen 8. Here 7 into 2 plus here 1. Here how many electrons? 8 into 1. The total 14 plus 8. 22 electrons in N2O molecule. But NO molecule, so 22 electron means this nature is of diamagnetic nature. NO, here 7 plus 8 is equal to 15 electrons. It is of paramagnetic nature. NO2, here 7 plus 2 into 8, 16. 16 plus 7, again 16 plus 7 how much? 23 electrons. It is again paramagnetic nature. But where is here? 46 electrons. It becomes diamagnetic nature. So now children, you observe here, you are given asked the question, neutral nature, paramagnetic nature. So these two are neutral nature. Which is paramagnetic nature? This is the paramagnetic nature, NO. That's why you can choose the correct answer, nitric oxide, children. So that is why correct is the, which is answer? B is the correct answer. Next, 14. A blue liquid among the following. So in oxides of nitrogen, the liquid state is possible for nitrogen trioxide. That is the formula N2O3. So it is a blue color liquid, children. Next, FeSO4 forms brown ring with which compound? Ferrous sulfate using your brown ring test. In brown ring test, here using of freshly prepared ferrous sulfate with nitrate test. In nitrate test here means here using which compound? Here forms of brown ring with nitrogen dioxide. So that's why here 15% here the brown ring ferrous sulfate forms brown ring with nitrogen dioxide. Okay, children. So this is about the classwork assignments. You do in homework assignments. Then ask the any doubts in the doubts clarification in my Pal app. Okay, children. Now, children, discuss about the allotropes of 16th group elements. Here, except polonium, because of polonium is radioactive elements. Remaining all elements are exhibits the allotrope property. So what is meant by allotrope? The same element exhibits the similar chemical properties but different physical properties are known as allotropes. Here oxygen allotropes are O2 and O3. Already discussed about the study of preparation and properties of O2 and O3. That is oxygen and ozone gas is over. Now we discuss about especially the most important allotropes here, sulfur allotropes. Here the sulfur forms many types of allotropes. Several allotropes are formed. Now the most important allotropes of sulfur is mainly classified into two types. Crystalline allotropes, amorphous allotropes. Crystalline allotropes are again here two types. Mainly one is rhombic sulfur, one more is monoclinic sulfur, and one more others also form angel sulfur like that. The main important crystal allotropes, rhombic sulfur and monoclinic sulfur. In both the sulfurs, the number of sulfur atoms are exist as 8 atoms. That's why rhombic sulfur and monoclinic sulfurs are octa-atomic molecule. That is representation of the symbol S8 and S8. The rhombic sulfur is also called, children, alpha sulfur. But monoclinic sulfur is again two types, beta form and gamma form. Beta form and gamma form. Finally, alpha sulfur, beta sulfur and gamma sulfurs are all are crystalline forms. Here, in alpha, beta, gamma, which is the most stable form? Alpha form is the most stable form at room temperature. That is called rhombic sulfur is the most stable of the sulfur. Whenever the rhombic sulfur on heating above 95.6 degrees centigrade converted into monoclinic sulfur. That means up to 95.6 Celsius rhombic sulfur is stable. More than 95.6 converted into monoclinic sulfur. Again monoclinic sulfur is on cooling below 95.6 degrees centigrade or 368.5 kelvins form the rhombic sulfur. That means your 95.6 Celsius temperature or 368.5 Kelvin's temperature is called the transition temperature. So what is transition temperature, children? The conversion of one allotropic form to another allotropic form. That is called transition temperature. So your rhombic sulfur is converted to monoclinic sulfur at what temperature? Above 95.6 degrees Celsius or 368.5 Kelvins. That's why this temperature is called transition temperature. But at 95.6 Celsius what happened? Or 368.5 Kelvins what happened? Exhibits the both rhombic sulfur as well as monoclinic sulfur. That's why what happened here? Equilibrium state is established at 95.6 Celsius temperature. Next, here the rhombic sulfur is more soluble in organic solvents like carbon disulfide and benzene, but insoluble in water. Whereas here also monoclinic sulfur is also insoluble in carbon tetrachloride. Then here the rhombic sulfur is S8 molecule. The S8 molecule structure is representation is it is the structure of S8 form of the structure. This S8 form of the structure, 8 sulfur atoms. Arrangement is like this. This type of arrangement is called crown ring structure. Crown. Your crown. And Miss Universe are using the in beauty competition using of the ring, crown ring. Like that is also called pucker ring structure. Crown ring or pucker ring structure for S8 form. Next diagram. Here the rhombic and monoclinic sulfurs are both are anisotropic sulfurs. Enantiomers. Nothing but anisotropics. Next, one more form is possible for sulfur. Angel's sulfur. Your Angel's sulfur number of sulfur atoms are only 6 only. That means the sulfur S8 molecule on heating up to 160 degrees centigrade, you are melted at 190 degrees only around. But on heating up to 160 degrees centigrade, the S8 molecule broken down into S6 molecule, as well as on heating high temperature converted into S4 and finally S2 units are also formed. But at 160 degrees centigrade, S8 is converted into S6. So the S6 molecule is a Angel's sulfur. But this molten sulfur immediately poured into the cold water, that is called plastic sulfur. That is also called Xy form of sulfur. The symbol is Xy. So the plastic sulfur or Xy form of the sulfur is formed. The molten sulfur is immediately poured into the cold water. The formation of the sulfur is called plastic sulfur. Whereas on sulfur is on heating above 1000 Kelvin temperature, that is called elevated temperature. Here finally it exists as S2 molecule. It is a diatomic molecule similar to O2 molecule. But that's why S2 molecule is behaves as the paramagnetic nature similar to O2 molecule. Next, remaining elements selenium and tellurium. Selenium also exhibits the 6 types of allotropes. Out of 6 here, 4 are red color and non-metallic nature. 2 are grey color metallic nature. That's why you know selenium is one of the metalloid or semi-metal. That's why here some are allotropes are non-metallic nature, some are metallic nature. So which is the stable form? Metallic compounds of grey colors are stable for selenium. Like that, tellurium also exhibits 2 types of allotropes, metallic, non-metallic. Here red and grey colors are exhibits. Here the crystalline tellurium is isomorphous with the grey selenium. That means here the tellurium allotrope is there here, grey color. This is isomorphous with the grey color of the selenium. So which are isomorphous here? Tellurium crystalline form is isomorphous with grey form of selenium, children. Very important point. Yeah, tellurium is O. Crystalline tellurium is O. Isomorphous with O. Dash. Which one? Grey color. Selenium is the isomorphous, children. See children, in allotropes of sulfur, the angel sulfur S6 molecule, it exists as a structure is a chain form of the structure. It is a chain form, just like it is a similar to chain. Your bond length is about 102 degrees and bond length is about 205.7 picometers. This is the structure of angel sulfur or S6 form of the molecule. You know already S8 molecule is a crown ring or puckered ring structure. Okay children, that is the allotropes of sulfur. Then next what we are discuss about the important here oxo acids of sulfur. Sulfur forms here mainly 4 types of oxo acids. These are called sulfurous acids, sulfuric acids, thionic acids, peroxy acids. So then here named as sulfurous acid means the suffix is OUS, that is called us acids. Like sulfuric acid, the suffix is IC, it is called ic acids. Thionic acids, they are written directly thionic acids. One more is about peroxy acids. So in thionic acids means in sulfur acid, so SS linkage is present. Peroxy linkage presence of the acids are called peroxy acids. You know peroxy linkage means OO linkage, adjacent oxygen atoms linkage. This is adjacent sulfur atoms linkage, especially are named as thionic and peroxy acids. Here all oxo acids of sulfur, the sulfur atom is generally undergoes sp3 hybridization and tetrahedral geometry children. Whereas each oxo acids of sulfur having 2 OH groups. These 2 OH groups are responsible for the basicity of acids. That's why here commonly the basicity is 2. That's why called dibasic acids children. This is common for oxo acids. Now we have discussed about some important oxo acids of sulfur as per your syllabus. One is called sulfurous acid. The formula is as H2SO3. This is the structure of H2SO3 molecule. Especially this molecule central atom is exhibits oxidation state is +4. That's why this is possible for second excited state only children. So here consisting of 1 lone pair of electron also. Therefore, 1 lone pair, 3 bond pairs are present as well as it forms 3 sigma bonds and 1 pi bond also. Therefore, the sulfur atom formed by 3 sigma bonds and 1 pi bond, the central atom of sulfur contains 1 lone pair, 3 bond pairs. The total electron pairs are 4. That is why it undergoes sp3 hybridization. Then observe your structure also children, 2 SOH bonds, 1 S double bond O bond is present. This is structure information for sulfurous acid. Like that, one more is sulfuric acid. Here also sulfuric acid is dibasic acid because of 2 OH groups, 2 S double bond O groups. Here consisting of sulfur atom, 4 sigma bonds, 2 pi bonds. Here there is no lone pair of electrons children. That's why the total 4 are sigma bonds, 2 are pi bonds are formed. Here the oxidation state of sulfur is how much? +6. This is sulfuric acid. Next one more is pyrosulfuric acid. Formula is H2S2O7. It is also called oleum or also called fuming sulfuric acid. Nothing but here SO3 is dissolved in sulfuric acid to form the oleum only. Sulfuric acid how to form? Fuming sulfuric acid how to form here? Sulfur trioxide is dissolved in sulfuric acid to form the oleum compound. So this is the structure of oleum. Here consisting of SOS linkage along with 4 S double bond O bonds, 2 SOH bond. Again, here both the sulfur atoms are oxidation states are +6 only children. Next one more is about peroxy disulfuric acid. This consisting of peroxy linkage. See observe here. This is adjacent oxygen atoms of linkage. That is called peroxy linkage. That's why this name is called peroxy disulfuric acid. Formula H2S2O8. Here both the sulfur atoms are oxidation state is +6 only children. Here the peroxide in case of atoms of oxygen, oxidation state should be taken as -1, -1. But remaining oxygens should be taken as here -2. Then only we got the oxidation state of sulfur is +6. It consisting of 2 SOH bonds, 4 S double bond bonds, 1 peroxylic gas. So this is the structural installation of your peroxide disulfuric acid children. Now you observe your 4 oxoacids of sulfurs all are dibasic acid. Why? Because each oxoacid consisting of 2 OH groups only. Okay children. So this is about the information for oxoacids of sulfur. Your study of mainly the important oxoacids of sulfur. These are 4 important oxoacids of sulfur children.